All right, so let's go to bus stop balancing. All right, so this is one of the newer tools in TBEST 5. And so we had this in TBEST 4.8, but it was kind of limited. It did not have a UI really for actually interacting with the stops and removing them interactively. It kind of just removed them based on a scoring total. But in this version, we have revamped it. So we have a full interface for interacting and balancing stops. And uh, so just as a definition of what it is an add-in. So it's not actually, it's actually runs as a separate executable inside of TBEST. It's under the tools menu. So it's, we mentioned the add-in capability. So this is an add-in to TBEST. It's not part of the main tool set. That's inside of the overall executable. It's something separate. Um, but what it does is it ranks stops for removal and balancing. So there's a whole kind of componentry to that we'll kind of roll through, but basically the user sets defined scoring variable weights in the setup window. So the setup window is, um, illustrate this. So this is the setup window here. And you define all of your inputs to the bus stop balancing, including the routes that you want to balance, the weighting of the variable scores, and then some other policy parameters we'll go through in a minute. And then once you run the scoring, it will produce this output that you can interactively use the scoring results to remove stops and balance them according to kind of how you would see them actually playing out based on scores and whether something is a stop removal candidate or not. And then, have some interactive capability with it. You can also export any of the results to the spreadsheet. So the table you see here can be exported obviously to a spreadsheet with all the variables in it. The map as well to ArcGIS Online or mobile geodatabase. When you export to these formats, it does have all of their variables in it as well. Okay, so let's get into some of the details of this. So here's the setup, right? So basically when we're starting out, we're going to select our transit system and our network scenario, and then the routes that we want to balance, right? We have a mobility area filter here. And one of the reasons that we do have this here is because a lot of times balancing is done locally, not necessarily globally in the system. So it could be that you're balancing stops in a region, and sometimes that region has its own policy considerations as to what the spacing might be in that area. So being able to filter by geography means that you can set spacing goals for that particular area that has its own kind of spacing context, right? So that's part of the overall setup is to first just select the transit system scenario, whether or not you want to filter by geography and the routes that you want to utilize. Okay. All right. So the other part of this are kind of four areas that are inputs. So we'll start with the stop variable score weighting. So you weight stop characteristics based on user-defined levels. So generally the highest level is going to be stop distance, right? Clearly that's part of this where we want to say, the closer that stops are together, we want to weight that very highly because those are the ones we want to, kind of remove. They're too close together. We also weight on connectivity. So if there is high connectivity, it will have a lower score. If it's low connectivity, it will have a higher score because we're basically tabulating and weighting these upwards. So the poorer the connectivity, the higher the score because we want the highest scores to be removed. So rider activity is that's based on observed APC data. So for like our our fall 2024 scenario in Gatorville has the observed ridership in it. So we would most definitely want to use that as part of our weighting and scoring, right? It's because the higher the ridership, we don't want to get rid of stops with high ridership. So that would also play into this. If we don't have this variable, we can use the estimated riders, which is weighted here. Population, employment, minority population, households, all of those are weighted as well. We also have this average vehicle stop dwell time in seconds. So part of what we're trying to accomplish here with removing stops is travel time savings. So if we do remove stops, can we estimate some level of travel time savings that we might receive out of it? So part of this, whenever we're evaluating this, is based on the ridership of the stop and the trips to it, how many times would it actually stop? So if there's really low ridership or there's no ridership at all, basically the bus will never stop there because there'll never be anyone there. There never is anyone there. So it would get the full 12 seconds. But as more people would be riding it, it would have to stop, right? So you would get less of the 12 seconds. And this we're saying 12 here, but this could be 30 seconds, whatever it is, that would be the dwell time. So it would be the deceleration, acceleration time, all of that can be included in this whenever you're trying to calculate this overall travel time savings. So that's a component of this as well. The other component is stop spacing definitions by density. So generally, this is like a policy kind of thing where in high density areas, the minimum stop spacing might be 750 feet, and medium density, 1,000 feet, low density, 2,500 feet. And then the density, here's where you would define the density per acre. And this would be population or employment per acre. So either one that is greater than 5.0, and then medium is between 2 and 5, and low is less than 2 in this case. But you can edit any of these values as well. When you do edit these, they are saved. So they become your basically bus stop balancing parameters, right, for your agency. You also have stop exclusions where you really don't want to, remove stops that are where the estimated ridership is greater than 30 or the ons and offs are greater than a certain number at schools or transfer stations, stopped facilities such as shelters and benches you wouldn't want to remove, or at hospitals. So these are just where you just don't want to remove stops. So all of these kind of combine to help us determine what we want to remove and not remove. Okay. So once we have set all this up, we run it. Okay. So we run the scoring, and basically it creates this table that is also a geodatabase. And we're able to evaluate all of these stops based on variables within that we've created, socioeconomic variables, some service variables, the scoring. In this case, we're rendering this route or the map by total population. So what you can see here is in the route map controls route filter, we're rendering by total population. We're also labeling by total population. So what you're seeing is that the stops, the greater the population, the bigger the circle, right? So yeah, so it's just a way of rendering out. It's very interactive, lots of render by options where it will just change the look of the stops based on the variable that you select. All right, so the main criteria here is to be able to select stops in using the list or using the map and then remove them. So, so this is your remove stops up here, and you can save the edits as well. One thing to note is as you're removing a stop, and this will kind of play out in our examples, it will rescore, right? Because once you remove a stop, that changes the stop distance between the stop you removed and the stop before and the stop after it. So those need to be rescored, and they may fall out as candidates for removal. So we'll talk about that in just on the next slide. Okay. All right, so here are the map controls. So just so you know, here are the control panel. So here's the map controls where you select a route to edit. You can render the map by input variables and scoring results. You have the labels. You can also do an equity select where minority population is greater than a certain percentage and hit apply, and it will select those stops. So if you need to filter stops by minority or low-income populations for Title VI reasons, you can do that. You have a density category. So we mentioned in the setup, we have high, medium, and low densities. So each stop is provided or assigned a density category based on the inputs per acre of people or employees per acre. We have balancing results display. So this is where you have, based on the policy parameters that were defined in our input, where you can define stop removal candidates and stop addition candidates. So generally what we're after here is stop removal candidates. But what TBEST does provide here is those areas where you could use another stop because you have the densities to support it. So you might want to consider where these stops are that are stop addition candidates. There could be a potential to add more stops there based on the density in that area. All right, and we also have this balancing exclusions, so we can toggle the visibility of our exclusion stops as well. So here's the high-level stop removal process where you would select a route. In this case, the example is Route 10. We are rendering by total score, and our label is total score. So you can see that these are very large in their rendering, which means that their score is high, but we also see their score as a label out beside it. So what you see here is I've selected this stop, which is in between two other stops that are also candidates. So the setup here is we have all the density categories enabled. So we can see all the density categories. However, we are only showing stop removal candidates. So based on our policy guidelines per density and our minimum stop spacing, we can identify candidates for removal. So here it's showing only those that are candidates for removal. We're not showing any of our exclusions, which means that we basically can't remove them, right? So we can only select those that are visible, and we've selected this stop right here. And so let's go on to the next slide. All right, so the trick here is that we've selected this stop, and if we move to the next slide, when we removed that stop, it actually removed two other candidates at the same time because they were rescored. And when you remove the stop in the middle, basically the two other stops, their spacings change because you removed a stop, so they're no longer candidates. So by removing one stop, you remove actually three candidates for removal, if that makes sense to you. So you're basically then saying, well, okay, by removing one stop, I've gotten rid of three candidates. I'm well on my way to doing this. So what happens when we remove a stop? It updates the summary at the bottom. So this is the bus stop balancing summary at the bottom. And so essentially it changes, right? So we have, and I'm going to show this in detail, but this travel time savings updates, the remove stops updates, and the stop spacing updates to show that, hey, we've removed stops, we have some travel time savings that's involved, and this will be cumulative. So as we continue, we'll start to see all of these change. And of course, when we save the edits to this on this save button up here, it saves back to the original scenario. So really what we're trying to do here is save this back to the original scenario to balance it. Then we could run the ridership estimation model and all those different things that we do back in the main TBEST based on our procedure here for removing stops. Yep. All right, so let's just look at this summary panel just for a second. So when we first came into Route 10 to start to balance it, it gave us the original numbers, right? So here's the summary. Here is Route 10 before bus stop balancing. You had 45 stop removal candidates. The stop spacing was 1,185 feet. It gives you low income population percent, minority population percent, employment and population. As you start to balance it, it will continue to update these numbers, and it will show you the travel time savings you have by removing stops, the removed stops in total, and the revised stop spacing as you're removing them. And the idea here is you get down to potentially 0 stop removal candidates. Now, it may not be 0, it might be some number that you're satisfied with. But the idea is that you can get rid of all of the removal candidates. You started with 45, you're down to 38. So you can track your progress as you're going. Okay, so once we're done, um, you can save the edits back to TBES. They're directly to the network. You can export the balancing results, but you can see the route before stops were removed was very dense for the spacing, and then afterwards it's less dense, and it's based on the ridership and the not only proximity, ridership, connectivity, all those things that we want to evaluate for relative to all of the stops. We score them relative to those in the weighted methodology. And then we can remove them in a way that we're not removing productive stops or stops that we don't want to remove based on their amenities, things like that. So that's the idea of this bus stop balancing tool, and then we can run through an exercise on it. And do we have questions on this?
Yes, we have a question. It looks like you mostly answered it, but it might be worth reiterating for the recording's sake.
Yes, you're exactly right, Charles. We should make a copy. We will do that in the exercise. All right. Okay, so I am going to close this scenario and kind of clean up here and consolidate. All right, so I'm on exercise 9, bus stop balancing. All right, so bus stop balancing prep. Within TBES, close any open scenario if needed, which we did. Within TBES Explorer, right-click on the Fall 2024 network and copy it. So we're just going to copy Fall 2024, and we're going to call it Fall 2024 balancing. And I think that's it. That's all we really need. Everything else is the same. All right, so in our task here, we're going to add another group, and we're going to right-click on the balancing scenario and move to a new scenario group. So add a new group, and we're going to call it Stop Balancing. We don't have to do this step. It's more of just kind of showing you can do it. So there we go. We have our new balancing scenario, and this is an important step. You don't really you obviously can't do it on the base. It won't let you balance the base. It's read only. But definitely you want to have a copy so that you can refer back to whatever original that you had. Okay. So the next step is we're on to part 2. In the TBES main menu, select the tools and bus stop balancing. Now it's going to ask you to log in again. So you'll just need to log in because it's starting up a new executable. Okay, so this is where we're at. All right, so we want to select the Gatorville system and our new fall 2024 balancing. And okay, we want to select routes 1 through 10. So let's just go ahead and select each one of them, 1 through 10. And then let's take a look at the stop variable weighting. So in the stop variable score weighting section, update the rider activity score to the value of 30 and set the estimated riders to 0. Now we're doing this because we have the APC data for this, right? So the base had the APC data, so we have that in this scenario, so we can use that for bus stop balancer. All right, so if you wanted to change the vehicle dwell time to more than 12 seconds, let's say it's 30 seconds, you can certainly do that. If you wanted to change your stop removal candidate minimum stop spacing and stop addition maximum stop spacing, you could do that as well. We're going to leave it the way that it is for now. In the stop exclusions section, we're going to check on the stop exclusions ons and offs and set that to 50. And this one we're not going to consider estimated because we have the observed, so it won't even consider it. Oops, uncheck that. I think we're all set, so let's hit the run scoring. All right, so it's going to generate the SE data for all the stops. So we just have to wait for a second for this to finish. So I'm going to bring this over, zoom out. All right. So here is our initial view with our control panel over on the left, our list of stops below, and our map result as well. Okay, so let's go. We're in part 3 now. Within this TBEST bus stop balancing results view, and the initial bus stop balancing results will be displayed within the map view and the results table. Use the results map view map control render by options to modify the map rendering to display the intensity of the available variables. All right. So very easily we can show a total score variable here. So it responds to that very quickly. Basically, the higher the score, the darker and bigger the stop. The population density is here. So you can see population densities at the stop level, employment densities, maximum or minimum stop spacing. Let's see, what else do we have? Total employment, total households, total population, percent minority, travel time savings, transfer opportunities. So here's your connectivity in the network. So all of these are available to you, weekday service trips. So it's actually a pretty great just in terms of being able to visualize your stops in different ways. It's a pretty quick tool to do that. Okay, so set the map label to total score. This is number 4. So we're going to set the map label to total score. So here's our scores. All right. And select Route 5. So we're going to select Route 5 from our list. Notice we only have routes 1 through 10, which is the ones we selected. All right, so here's Route 5. And we want to make sure okay, so it's saying to sort by total score here. So basically, we have our total score. We can see that in our listing, this is our first stop with the highest score, 234.4, and on down the line, right? So it's just an easy way to look at total score to kind of see which ones are priorities here. All right. So I think before we do anything here, we want to make sure we're filtering, right? So we just want to see stop removal candidates on this route. And we don't want to see any stop exclusions. So essentially, in our listing here, we can see high, medium, and low. All of that is fine. But we want to get rid of stops interactively. And so basically, the best way to do that is using the map tool. And because we know all of these are considered stop candidates for removal, and they're in either direction. So either one of these is fine to remove. Basically, if we look at these and want to see the higher of the two scores. So this one is 234.4, this is 233. So we're going to just click and hold or select that stop and remove it. So when we remove it, the other stop goes away because it's no longer a candidate for removal because its stop spacing is different. So essentially, the process here is to look for the higher scored stops and then remove them. And then generally those will be remove stops around them. So let's remove this stop. Yep, that removed other stops. So 194, 181. So let's get rid of this one. And probably need to get rid of one of these. They're both about equal. Yep, they both went away. All right, so basically we're getting rid of stops. We're balancing them based on which ones are candidates. And if you notice here in the travel time savings, we're up to 99 seconds of travel time savings. We've removed 4 stops. Our stop spacing has changed. It's now 1,125. So we can just keep going and keep removing any of these candidates. Here's 147. That one is higher than this one, so let's remove it. And that one is gone. We'll remove this one as well. You can remove this one. And on down the line, right? So these are all candidates for removal, so we're fine to remove them. There's no exclusions or anything on them. So let's just remove them. All right, so this is interesting. It popped up and said the selected stop exists on multiple patterns and multiple routes, including the following Route 10. So this exists on Route 5 and 10. So do we want to remove it from both? Yes, we do want to do that. So we'll remove it from both. Again, we'll select this one, remove it, and remove this one. Remove this one. All right, so we're just down to a couple here. Let's remove those. Remove this one. And one more, and that's it. So all of the candidates, so we don't have any more candidates. We can now save these edits back to the scenario that saved successfully. So now Route 5 is now changed in terms of these stops, right? Back into the original scenario. All right, great. So all right, so when we're done, let's go ahead and close this out. We've saved it, so we're all good. All right. So the next task, this is part 4. Within the bus stop balancing window, the mobility area geographic filter, select the downtown redevelopment area. All right, so in our filter, we have a downtown redevelopment area. And so what that does is filters the list of routes that intersect with that area. And so we can select all of these and hit the run scoring. Okay, so what you see now is we just see the stops that are in the downtown redevelopment district. So we don't see the stops that are outside. So we're just balancing what's inside. All right, so if we select Route 10 from this list. So now we just see Route 10. We just want to see stop removal candidates only. And so basically, we don't have any candidates, what it looks like. So that's good. We don't have any. And I think we removed them actually from removing those from Route 5. If we wanted to go around and look for others, here's 6. So we have some stop removal candidates here. So we can do our labeling on stop total score again and rendering on total score. So we can kind of see what these look like. 204, so definitely this one is one to remove. So we can go ahead and select that and remove it. And we do that. That one exists on Route 1, 25, and 46. Do we want to remove that? Yes. So that actually got rid of the other 2 candidates. There's one more candidate up here. We can remove that and click remove. And then that's all of them for 6, right? Yeah, so that's all of them. So we can save that. Save successfully. All right, so that's kind of it. So now we can close all of this and we can go back to our bus stop balancing. And if we go to our fall 2024 balancing, our Route 5, definitely looks like it's been filtered out, right? So less stops up here, here, and here, and definitely kind of balanced so that it's based on the criteria we selected. And so we have a balancing system that we can use to judge what we would want to remove and then push that back into our scenario. And from here, we just run the ridership estimation model, or even use our tools for ABC ridership data, because that's in here as well. We could still use those tools. Yeah, so that's kind of the bus stop balancing. I don't know if there's any questions related to that, but pretty cool tool that's new that you can use that when you're editing stops to do some consolidation if you need to. All right.